and correct me. So today's topic, I will share my screen and probably start. Is it okay? I think it's
absolutely.
time to go. All right. So
Yeah,
I will share my
And if you have any questions, you could write them in chat. So I will manage chat questions and will like notice you, viewers, if you have some question in chat, or you could unmute yourself and ask questions directly. So don't be shy and use this great opportunity to ask Ivars, because he's an active practitioner, so he could share his actual experience with you.
Yeah, all right. I will tell a couple of words about myself first, and then I start. Let's see, like that. Yeah, I run Excel know-how website, and we do help people train themselves, and as well we do service and do some solutions on Excel and Power BI. All together, we have a team here, and we sometimes write a blog and sometimes advertise. So you could probably seen me before. And yeah, I'm in Power BI Meetup for a long time already. And today I'm going to speak about Power BI calculated tables. So what is it actually? And I will try, let's say, break it down in some let's say some points that I see valuable for where I found tables very good, and maybe I will try to drive this one into the direction where I feel comfortable, and which scenarios I have been using for a time and found very, very useful. So I will share that with you. So if we go back, there are many functions, let's say not really many, but many functions of table manipulations in Power BI. I will not be telling about all of them. Let's say just shortly what it's good for. We can create lists like dimension tables. We can filter data with tables. Often if you have been using calculate function, then you have used the filter function inside that as well. So that's as well a filtering function, but the filter is actually a table of data and returns some sample so that actually calculations can be done. And we can use you can use DAX table functions for joining or appending data, like you mentioned all this that natural joins and cross join functions, and that's that as well. But which the two last points that I'm let's say more fan about is like that we can group or summarize data, like do some aggregations, and do some mixed activities like grouping and summarizing, and let's say grouping, summarizing, and filtering data. So it's like a mixed activities that you can do. And I will show some let's say basics before, and then we'll go to the samples as well. So what I have here, I have a couple of slides, just really 3 or 4 slides here. So what you can do is, and I will be more focusing on, let's say, I will show this benefit of using DAX table functions in measures. You can do it in both. You can do it in DAX like a static tables, and you can use them in measures. I hope you have used them in both ways, like probably have. If you have used calculate function, that then you have used probably filter function in there, so you have done it. But I will go a bit further there. Static tables use memory, and but tables in measures use processing power. That's neither good or bad. It's both ways. It depends on the model size and the calculation volume that you need to process. That's just the thing you probably need to bear in mind, that when the calculation is done in a measure, then that's done using a processing power, and then there are some limitations as well in Power BI that you can actually achieve. I will hopefully show that later as well. Static tables are calculated once when the model is loaded, and you cannot apply filter context on that. So it's just a static table, as if that would be loaded query, Power Query. Like just it's calculated before. Probably there's some scientific terms before that as well. You can explore that, but let's say so it's a static table that you calculate once and that's it. While measures tables are taking in the context the filters that you use, can use that, and they are calculated dynamically. So, and my scenarios that I will show you today, I'll probably try quickly go through these simple scenarios, like you can use distinct and values and calendar auto. That's a basic stuff everybody knows probably. Then simple filtered list, like filter and calculate table. Then there's a bit more of a fancy thing is that you can join and append tables as well. It depends on solutions that you actually need to do. I have used probably all of these functions except natural join in everyday life, and many times I've used the summarizations and summarizing and filtering things. And the two last topics, which is probably is the main idea why I came here, is how we can calculate averages from grouped results. For example, if you have a list of transactions, then how you can calculate a daily average, for example, or annual average and things like that. And then there's another one which is inspired by one of the clients that I had a chance to work with, is actually making like a client patterns of how many distinct clients do we have. It's an easy one, but let's say how many clients use one service and don't use other services, and so on and so on. And then at the end, let's say how much money they made to us. So does that sound good for you? Is that just say me in chat that you're really happy to hear this, what I'm gonna talk. So all right, average is going back. I have a sample here, and I will just, let's say, there's lots of stuff in there here, but I will just try to make some of the samples. I hope you see. And let's say, obviously, a simple measures. Yeah, I came to measures already. So let's say tables. I will create a new table. I will write it like a Z table. Let's say distinct. Everybody knows that probably. You can make a distinct table, let's say, of, I don't know, country names from sales data, for example, like that. It's just simple as that. I'll try to make it that. So you can do various things in these things. Obviously, I have made many of those, but let's go any further. You can also do some filterings. I will not go. I hope it's okay for you for the basic stuff. I don't cover that so detailed. So Z, for example, I will take some filtering, and you can do some simple filters like filter, let's say table of manufacturers, let's say products table, and we have some, let's say, categories there. Category is, for example, mix. I'll actually probably need to show you data what we have there. So we just filter a table, return a table. That's pretty basic. You use that function in calculate so that you can have a context, and so on. So I think that's pretty obvious. I'll actually come back to show what structure I have so that it's easier to understand. I have sales data, which is just a number of transactions. I have countries derived, and I have products, and I have manufacturer. This is the basic structure of the tables. The rest is just a mess around it. So let's say all my experiments here. Let's say. More fancy. Let's say we have a, let's say, calculate table function, for example. Calculate table function.
Ivars, could I ask a question?
Yes.
Very shortly, could you say from the practice when do you decide that you need to create a calculated table?
Yeah, I think whether I missed it here from here. Yeah, for example, let's say it's good for example, we do, for example, if we have a sales data and we have many rows and have the country name in there, it's actually very handy if we spin it out and have a single table of country names, for example. It's just basic as that. If we have two fact tables and we need to maybe to make it a distinct table of two of these distinct let's say these ones, the countries, for example. I don't have actually a sample here like that. Then we actually can make together these two and make a dimension table that we can filter off. That's a basic part. But let's say the other thing is I say we filter something out if we want a separate table. And I love this like aggregation part that we make aggregations pre-aggregated data. I will show of that as well a bit. Some mixed activities like grouping and filtering so that we actually have some context of that. And I will show how to then use that into the measures. That's my like aim here. So, all right, I will go back there. So I will go back here. I think the question is about denormalized manufacturers into products, I believe. Actually, all right, I'll actually probably come to that a bit later. So, but anyway, let's say if we make another table, for example, it's just really a mechanics of doing that a bit. So, and then into the samples. So let's say Z table, so that it's a like calculate table. Calculate table is like a very interesting function that you can like have a let's say filter and derive a table in that. So for example, I have like a values of products, let's say in product table, and let's say I filter them out that category is let's say the same mix. I remember for my easy. So let's say we have, let's say we can derive, let's say, a list of something which has a specific filter. It's probably I will use later on from sales table zip codes. Let's say I have a zip code that actually use this figure in a mixed category, for example. And I don't use, let's say, full table. I just have for example, one column here. So that's kind of a, let's say, mechanics of that. Then which I really like here is we actually here I have a sample of summarization, for example, that I have done is we do a sales data summarization by year and by total revenue. So it's a static table, and if you do that, you can calculate the average of this column and say, let's say average turnover per year is something, let's say like that. All right, I'm probably messing up here a lot, so sorry for that. If you follow me still here, it's okay.
We have some questions in chat.
Yeah. Let's say Leva is asking, but when do you use DAX and when Power Query? It's like my first answer always is how competent are you, and then in which place it's easier for you to do, then you start with that. But otherwise, let's say if we use static tables, then it's probably irrelevant. Let's say it's I would say it's both ways. It's easy, but if you want to do a DAX calculation, which is dynamic, then it's only in DAX. Let's say pre-aggregated tables. It will never give you that opportunity to make a dynamic calculation. Let's say it's harder, much harder. So I will show that in a minute, actually. So just some mechanics of that, and let's say I have my notes here. So that grouping and summarizing. Yeah. So this is like I can summarize a table by something, and so probably its function. A function works very easy. Let's say I do some another addition, for example, country name. Okay, it's fine. I'll put another one. So we actually will have a summarization by year, by country, and have a total revenue. So now it's a bit different. It's actually very often used, let's say, when you really want to take, let's say, get rid of transaction data, or let's say, sometimes I've done this like stock interim results that you can make it in like a snapshot of the probably of the last results and something like that. So it's use cases might be very many, let's say many of them. Is a summarize and a calculate table the same? No, but in some of the functions that actually works similarly, but not exactly. I've made some other let's say complex example. Yeah, for example, here is actually double. I will try to do some other here. Summarize sales data by let's say source name, revenue, and a filter that calculate table by manufacturer's ABAS. Let's say like that. Yeah, I think that's gonna take a bit of time, I think, but I think it's because I've put my computer in a okay, I don't know why it's like that now. Yeah, it's fine. So we have summarized sales data table by one column, by revenue, and let's say with calculate table we've done a filtering part in there. So with summarization, if you do a summarized table, then it's not possible to filter unless you do a filter as I did before here in the let's say submit not just a table but a filter or filter table inside of it. So calculate table evaluates a table expression and can filter that. So it's both ways. It's sometimes let's say easier is to do one way, see if you can do that by one way, or do it by other way. So I'm not going to be very scientific about that probably. So so sorry for that. Is it good? Is it possible to do group by and etc.? And the group by is actually the same. This summarize. We can do this summarize. I have not used this group by function too much. There are slight differences. If somebody knows here, can tell me, can tell us all. But I've been using the summarize function when I first read it, and I found it enough good for me. So I'm not dug too much deeper on that. Yeah, and then there's another one. Love to hear for static tables. It depends on what it now best, since DAX is currently the same as in measures. All right. Yeah. I like to do it in DAX. A lot of the things in DAX. I don't know very well mQuery, so I focus on DAX more than on mQuery. So, all right. If you do a bit different here, for example, do not supply a summarized table, but let's say table, let's say column from values of source name. Let's say like that. Let me see if I missed anything. We can do probably the same, but we don't have this summarization here. So we can have actually like that. So there's lots of play around these things, and we can go on and on about this. But let's say I'll probably smoothly move towards this main topic and see that. So let's see. I'll show you here. I'll hopefully you can see that. What did I hear? Let's say I have made a couple of tables that. Actually, sorry. I'll go here. I'll have a topic here. So averages from grouped results. And let's say we need to calculate average of an annual revenue or daily or monthly revenue. And we can, what we know how to do is like simple average, and we can do but the simple average doesn't give us an average of a year or average of a day. It gives just an average of all transactions. Now, let's say if we go back to the model, and if we have an average revenue, for example, I will make a new measure here. New measure, a simple average Z. I will have like that. That's our average from column will be sales revenue. So sales data revenue. And I will go to averages and put it in here. So actually I have put it in there already. So it's all right. I'll put it in here. And average revenue I will take out. So that's my. So what it gives us is it just gives a total average of each transaction. And what I need to do is actually make some grouping before I make an average to make it annual or monthly or daily average. So let's say we do so. Let's say we do a new table, which I already did and I showed you, which is, let's say summarize, and I take this country out. I will take this country out. So this is like a summarization by sales data of year and revenue total. So this is an average. And if we go to visualization and do this average here, let's say it's a new measure. And I say average static table. I'll actually check the relations as well. And I see average by, so table calculate table, was it that? Summarize, table summarize. And by revenue. All right. So you see the number is the same as per year. This 1999 number is the same number, which is obvious. But the bottom line, the average gives us the average of all those numbers. Yes. But this one gives us a total as a sum. So if we would, but here average gives us an average of each transaction. I think it's. I hope it's understandable. It's fine. So, but if we do some filter on a country or any other place, so or categories, this number stays the same. As I said before, then this table. Summarization table, that doesn't filter. That doesn't filter with the context. If we go and use this summarization in a measure, let's say we make another measure. So I'll just probably just a cheat of that, a bit of a cheat. So, and we use this average dynamic. And then we use, I will make a variable, like a variable, and say table summarize, let's say table summarize. And this same table function, I will put in here, like a summarize, and make this function here inside the measure. So I will rename this to another name so that we are sure. Revenue, say summarized, and go to the next line and use this return function. So, and here I've got already a table of all values. What I need to do is calculate an average of those numbers, and which I will do is an iteration function average x. Use the table which is currently calculated, which is T summarize, which is now the same table, and use revenue sum, which is now of this virtual table field in here in this this calculation. So while this summarization is happening here inside the measure, we can use both the table and this new fields from this calculated column, calculated table inside this measure. So let's see what happens here. What happens here? The result is the same in the first look, but if we filter it, it works fine. It works with the filter. So this is one of the use cases that I use calculated functions inside calculate tables inside the measures to gain this ability to use filter context so that we can actually see the value dynamically calculated. So how do you like that? How do you like that? Is that useful? It's going to be useful, hopefully. So hopefully that's going to be useful. So I will put it here to see that this average is actually calculated dynamically for everything. So if you see the total is here. It is the same all over the model, and it calculates dynamically in filter context with everything. So that's one part. Let's say I think I covered this topic. I will see if I had something else here. I think it's the same thing. It's nothing else. So yeah, good. And now I will show a bit different topic. I will show it here. The next one use case is let's say we need to calculate number of unique clients. And in this particular model, I don't have clients. I will use zip codes, which are let's say pretty much unique. Will fill in for clients. For a simple number of clients, it's easy. We do distinct count. Distinct count is easy. But what to do when we want to calculate number of clients using one particular product, or let's say a particular product, and then maybe number of clients that use one particular and one another particular product. Let's say both. Let's say they bought this one product and they bought this other product, and then there is another case scenario when you say, okay, I want to know who bought bread and who bought I don't know, milk, but never bought cookies. Let's say so. Yeah. So and you can make these patterns of clients. Then say, okay, I have so many clients using these services, and so many clients that use both of those services, and there's so many clients use neither of services but use the third one. So this is kind of lots of magic can happen behind that. And then is a good question at the end is, what about revenue from those clients? Revenue from those clients. So how to do that? So that was a challenge for me for a long time when I did that a couple of years ago. Nobody could answer me this. And then I found a solution, and I'm going to share it with you now so that you can save your time. All right. So first, what I'm going to do is I'm going to calculate the distinct number of clients. Right, that's kind of easy. The Meetup measures, let's say distinct number of clients. Let's say go back to the model a bit to show the data. From sales data, I have the zip code, which I will call clients. Let's say this is a client for me in this point. This is as best as I can get. So they bought something. They're coming from different countries. They have different products, the categories, and I will use categories, which I have 4 of them, to filter those guys into different. So I think somebody's drawing on us here. So if you can all this delete those drawings. Actually, somebody is doing drawing here. All right. Okay. Distinct is. Please comment on that if that previous one was good. If go on static table. All right. I'll actually answer that a bit later. Probably I'll look at this so that I don't spend too much time on that now. So distinct, unique number of clients. I'll call actually zips. Yeah, it's easier here. Zips. So we use distinct count of zips in sales data. Okay, in sales data. Super. Let's say, and then we can actually see how many unique clients or unique zip codes we had over each year. And then we can use different context and products and whatever measures, and we can do lots of different parts of that. Then we can do, let's say, this other one is, let's say, how many clients used one particular product. How many clients used one particular product, and that's kind of an interesting how to calculate that. It's like we need to filter a table of sales and filter that by specific product or specific category here. So, and I will just come back to here, which I calculated previously, show you, for example, I actually calculated here now. Yes, for example, here. So we had a calculate table function, which calculated these particular zip codes for one category, let's say mix category. And I will use this function, which I will transfer neatly into this measure. New measure. And let's say I will say clients in mix, zips in mix, yeah, zips in mix, using mix. So for example, like that. So I can't just copy this formula here. What I will do is I actually again make it as a variable. I just like variables very much. I will say t mix. Let's say that's going to be like that. So that's my table of unique users return. Let's say like that, and I will use a function of count rows, and I will just count rows, how many rows we have of this t mix table. So if we have a list of unique IDs, we just can calculate it by okay, t mix is already used, zips and mix is used. All right, zips and mix. All right, let's see like that, how it works. So now we have let's say number of unique clients. We have 2,300, and clients that were buying mix category products, we actually have 627, but altogether 1/3 of all the clients were buying this mixed product. Not everybody, let's say 1/3 of them. So we know that. Well, let's say, and this is not a sum of them, and that's the most let's say it's the best part, that this distinct works all over the period. So we have years. So 2 years together. Let's put 2 years together. So we have here is like 2,900, 2,000, about 3,000 almost, yeah. But it gives us the unique number of 2,500. So let's see how it works in filter context. And we actually can do both of them in filter context. So now it's flying. This table is working in a filter context. That's the best part of it. So, and from this, actually, we can go further. let's say we want to do another one, and let's say I just copy this and make another one. Let's say who used our product in mixed category, and there's another category, let's say rural, for example. Let's say mix and rural. There's two categories. Let's say maybe I'm lucky here. So, and I will copy this one and say I have this other table, and I say T rural. Same function. This, by the way, the values function, it works very similarly as distinct. Basically, it actually would work here as well if we put distinct. So it's like a unique number list of items. I think somebody can let's say distinguish what's the big difference with them. There's not a big difference, but there is some difference. I will not tell you now. But let's say, as I found this example previously from this one, I've continued using that, and I use rural here. So let's stick with that. So I have this second table in here. So I need to now use it somehow together. So what I want to do is I want to mix them together. So I have zips in mix category, and I have zips in rural category. So I want to find out who matches, who is matching. So, and I actually have here a table, a function already in here. Let's say we can use two functions which are interesting, is intersect and accept. Functions that intersect finds out who matches in both, and accept is actually excludes the other ones out which are not matching. So I will use both of those functions, and I'll show you how it works here in this. This is my new function. So we use this count rows, but we will make another function in a table in here, which is intersect between tmix and trural. So that's my table here, which is mixed together. So intersect, which both zips from both which match, they will be retained here, and that will give us the count rows of all table. So let's see how it works here. So we now here see that this is a kind of a very popular category that most people who bought in a mixed category, they've been found as well in rural categories, but still we see there's some difference. Let's say come here, and we see some slight difference here. Let's say we can put it here. And the question from Levi is, can you do more than one intersect argument? Let's say argument in intersect, we can do one, but two arguments only, but we can use multiple intersect combinations, and I will use that in a minute. So, and this is kind of easy still. And then I had this other question from my client is, how can we do that we exclude, let's say, I want to know only those that use this mix and rural, but didn't use these other ones. And I will just sneak peek which categories I had there. Other ones is, let's say, the categories we have mix, rural, urban, and youth. Yes, urban and youth. So I don't forget that. So let's see. Initial question there was about this denormalization. Sorry, this is one of the training files. This is just for sample. I usually do not do this here. So it's just a sample of things and things that you can do. This is not normal. So we, let's say, use normalized tables wherever possible. So now I understand this question, which was first said. All right, let's go further on, and I will just check this formula and take it as a copy. and let's say like this, and make another copy here. New measure. And this question will be, yes, about more than 2. I will just show it here. So mix rural, and let's continue this fun with that. And I will put another one. I will put, in fact, another one. And this will be my urban category. And this will be my youth category. But see this, if you have like hundreds of services, and then this probably will not work like this. This is not good. Maybe there's some automation. I don't know. Maybe somebody can tell that. But sure, there should be some. But maybe some other technologies need to be used here. But let's say if I have only 4 categories, and with this client we had probably about 10 categories, and we could actually manipulate with these, but so like that. Still, so we have all those 4 here, and now I need to make some more manipulations with that. So actually I will say name this like only, so that they haven't bought any other. So I need to exclude them. So I have this table, which is my base, that these are the guys that have bought these products. This is cool. And now I will exclude everybody who has been using the other one. So I will do this like except, this is my table intersect. So this is first argument. And the second argument will be this T, let's say urban. Let's start with that one. So like that. So now I have this third argument, which says, let's say these guys are here, but I want to exclude those guys out. So if they bought this other one, I don't want to see them. So next, there's another one. I will need to put another one around that, except again, and let's say like that, and let's say like that. We go there. And we put another one here and put this T youth. So, and I hope I have all the brackets in place. All right, seems fine. So, so I hope I'm not disappointing you in here. So actually so we have this one, we excluded another one, and we excluded another one. So let's see how it works and what they have done for us here. Look, let's see like this. Yeah, let's see like this. Yes, super. Here it is. So there are a couple of guys, there's a couple of just really handful of zip codes or clients that have been using only these 2 products. So there's really not too many of them. And I guess if we would make this only zips only in mixed category, sorry, then there will be even fewer of them, because we see they intersect too much in these 2 categories. So we be even less. And this fun part is this works in a filter context. That's the best part of it. So it's just really because of that. Otherwise, we can do that in any other place. We can pre-aggregate it. We can do it in Power Query. We can do it in SQL. Everywhere we can do that. But this wouldn't work if we would say this wouldn't work in filter context. This is the fun part. So, and you see at the bottom here, there's 0, there's null, because we see that there is actually a place where there's a gap. So actually we don't have, sorry, it's not because of this one. There are none of clients that have never used these other 2 products in these 2 categories mixed together. So there are some clients in one particular year. There are some particular clients in another particular year, but none all over the period of data set. So how about that? How do you feel about that? So I'm starting to feel very good. So, all right. I'll check what I have missed, and I have, I actually covered now number of clients in more particular product and another particular product. So now about money. For example, if I wanted to calculate how much money those 4 clients spent here, I'll say how much revenue we gain from those guys. So that's kind of a tricky because let's say we have here an easy one. We have let's say this expression gives us the list of zip codes, list of clients. That it doesn't bring us does not bring us together with some revenue data. So it's just really a number of clients, or let's say a list of clients even. So what we can do is actually put that not into the function of count rows, but put that in iteration function around. So I will copy all of this so that I'm cheating. So here, let's say new measure. I hope I don't mix this up because this is interesting. So let's see, and let's say zips into revenue. So count rows function doesn't work for us here. So I will say SumX function. And we need to do this table. We need to put the table in here. So this is good. We have a table. We have a table of zip codes. This is fine. What we need to do is we need to put another argument of what we need to calculate. And actually, it's very easy. We will put a total revenue here. So we have a normal revenue, which is sum of the column, and we'll put it in here, and this calculates very well. So let's see, easy peasy, lemon squeezy. Yeah. So fun part is here. We actually can calculate, and that can go in the filter context. Let's see, I sorted it here wrong. So, and it goes in a filter context, and we see that these guys that bought these 2 products and never bought anything else generated us the revenue of 186,000. If we put this total revenue in here, too, then we can see that this is like really fraction of all the total. So if we're looking for these 2 ones, so this is this like fun part of these measures. So, but let's say we have still time, and I will try a bit discussing here what happens in behind the scenes, and where's the problem as well. This maybe looks too fancy, too fun, but let's see each of these cells here, or let's say intersections, they perform a number of calculations. We have, for example, here in sales data, we have not too many. We have this 1.3 million rows, let's say. Okay, this is a very small table. Let's say, but imagine you have many rows, and each of these cells perform a massive amount of calculations. Let's say this visual performs a massive amount of calculation. Let's go here. It calculates 4 times a table, and it filters everything out. So it actually filters 4 times a table. Then does this performs this action, just like intersect and accept, and then upon that SumX function, which is actually an iteration function, which is let's say slowing things down let's say often. Let's say I'm not suggesting to use SumX functions where you can use them not, let's say, where you can use other functions instead of that. But so
Ivars, can you show it in performance analyzer?
I probably haven't turned it on here, so probably will not. I'll tell from experience here. So actually, is it possible to turn on?
Under view.
Yeah,
Performance analyzer.
Yeah, sorry.
Start recording and then do refresh of table.
Okay, let's see, and we can do something like this, yeah. It doesn't seem much here, so it doesn't seem much here now, but let's say table DAX query doesn't seem much, but my experience is so if you have a massive number of transactions and this performs in a very many, let's say this filter slices here, it actually in desktop it performs much better than on a Power BI service. And on Power BI service I have run out of visual capacity. It actually has this capacity of 1 gigabyte of traffic that it has to send, and that's very easy actually to overcome because it actually sends back and forth data, and probably that's it needs to optimize on these ones, but still, let's say on small data sets, I'm very happy to use this one. So yeah, can you explain me? I think these are really small numbers here. I think this doesn't make a difference here.
Yeah, it looks really fast.
Yeah, maybe it's not that bad anymore. So maybe it's optimized. Maybe 2 years ago it was bad. So so yes. This is not an everyday content that I teach in my courses, but still we do a lot of full stack training on Power BI for in Latvian language. We have an on-demand course, so everyone who is interested really in Latvian language studying Power BI. Welcome to contact me, and that's fine. Or if you think I can help you in your DAX, definitely as well. But otherwise, I hope you find this really useful. So if any questions here, I actually am ready to answer some of them. I hope I can be on the fly and answer those.
Yeah, thank you Ivers, so much. It was really super.
Yeah,
super.
I probably went into the deeper part before I went to the smaller parts, so so easier parts. I hope it didn't overwhelm most of you. So, Yanis wants to ask a question, or yes?
Yeah, I have a very tough one.
All right.
How many years you have experience in Power BI?
Let's say, Aldis, when did you attract me? It was, I think it's now it's full 5 years, definitely. I think in 2016, in the summer I started, and in 2016 I made the first international project and training and everything. So it was very good, yeah, very fast. Development. But let's say don't bother you with these questions. 1 year is good to start, and then if you catch everything up, then within a year, I think you'll be good. So.
Then there's one more question. Before that, how many years you know the structured query language?
Which language?
Structured query language.
I don't know that language. So that's. I am an Excel. I'm an Excel guy. So I'm from finance and from Excel. So I'm not a programmer at all. This is my fun part. I've done this my own way, and that's why it might not look maybe too much academic and maybe not so scientific. But that works, and I'm oriented to get results rather than theory. So that's
no. Okay.
But yeah, Excel is 20 years of Excel. So let's say so.
Yeah. So I got the answer for the first question. Why there's 5 years, and yeah, that's very nice.
Power BI is only 6 years. 6 years here from 2015, was it? Yeah. So
yeah. This year it will be 6 in summer.
This year in summer it will be 6 years. So. But there was a Power Pivot in Excel before that, so shame on me, I didn't enter that before. Aldis was telling me that for 1 year, I think he said me, Ivars, try Power Query.
Okay, but I see that this is very nice because usually, from like I see it, you usually learn this structured query language. That's the fundamentals of all that. But here you can get this visual, and that's wow, that's very neat because it's very fast. You just drag and drop, and you get the result. And that's very nice.
Yeah, let's say Power BI itself is like that, but let's say the DAX is like really fantastic in that sense that you let's say in my perspective, for smaller and medium-sized companies here in Latvia or everywhere else as well, it's just really a fundamental change because they never had an opportunity to work with such a deep level analytics, and this is really almost free of charge. Like you can do it, and you couldn't do that in basic Excel, never. So and now this is really possible. And then if many people of IT talk about the pre-aggregations and databases and data warehouses, these ones as well do not do this dynamic calculation. This is the one that does. So this is my fun part. That therefore I'm standing for DAX and say, let's say, do it in DAX. So
okay, this is very nice. The one example that you mentioned about this grocery stores and so on, that is very neat because they actually use it by, for instance, placing the second item not near the first item, but directly somewhere else in a different corner of the shop that you need to went through all the shop to find the second item that you want to buy. And during that time, you can buy something else because you see different kind of things. So it also could be automatically done like that. Nice. Yeah. Okay, thank you.
Yeah, Preet, we are metering the time. Now it's the CSV files here on desktop. There's 5 of them. So it was some 25 seconds now here. I'm gonna tell you that CSV files are not very fast to load. If you would have these 1 million rows in some database with good, let's say, connection connection speed is one that affects that, and the server or the database server that runs it is that affects. But basically, 1 million rows is nothing. That's really just piece of cake. And I listened to this SQL BI and Guy in a Cube discussion about the big data and problems with that and mistakes. And they said that the big data, in their terms, starts from 1 billion rows, 1 billion rows. So if somebody says that 40 million rows work, they can't get into the memory or can't work with that in DAX, then they're doing a bad DAX. So that's just a simple answer. So this is easy as that. So yeah, but I think in here we don't talk about billion rows. Maybe somebody has, but let's say my clients, we use about, let's say, 50 million rows is like a average maximum that I see. So I don't know how many other people see rows.
Yeah, same for me. 50 million rows. It's something that usually we have, and for billion rows you need to use some aggregations and stuff like that.
Yeah, no, we use aggregations. Try to use aggregations as well for smaller parts. So it's no point of using many million rows as well. So it's like you just simplify data as much as you can, strip everything. So this denormalized data is not good sample. Just you can have many rows, but let's say only 2-3 columns. That will be much faster than many columns and less rows. So.
Yeah, and one more benefit from all these calculated tables and stuff, and now when my Power BI supports composite models, when you could load some tables in direct query and store some calculated tables directly in Power BI Vertipack engine, so you could combine them together. So do it together. So.
Yeah, there's actually a lot of information to grasp on. It's hard to keep up with all the news. So it's actually not very far away that we have to specialize in some small part in Power BI as well. Not just, let's say, we were in a conference a year and a half ago, and then these guys said, let's say, if you do Power BI, you do not do this Power Platform, or if you do Power Platform, you do not do Power BI. So it's like specialization. So I think we're gonna get even more specialization here as well. So it's too much to know already. So at some point, so and visualizations. All right.
Okay.
Thank you very much. And there's many people watching. Really appreciate that. Thank you. And Aldis, thank you again. So
yeah, thanks for coming, and see you next time. So thanks everyone, and have a nice evening.
yes,
Bye-bye.
thank you very much.
Thank you very much.
Yeah.
Paldies.
Goodbye.
Thank you.